Okay, so we started talking about circles and tangent lines and secant lines. Now we're going to talk about arcs and chords and their measures. The first thing we want to look at are central angles. And a central angle is just an angle whose vertex is the center of the circle. So angle ABC would be a central angle in this picture. And the nice thing about central angles is that whatever they measure, the arc that they create is the same measure. So if this angle is 30 degrees, this would equal 30 degrees. And an arc is just an unbroken part of the circle. So we're going to name them two different ways. If the measure is less than 180, we're going to use two letters with the arc symbol. And so, for example, for this picture here, if I were to name this arc, it's less than 180 degrees because half of a circle is 180. So that's definitely less than half of a circle. So I'm going to use two letters to name it. Okay, so I would just say arc AC, the starting and the ending point, and I would put this little symbol on top for arc. If it's more than 180 degrees or 180 degrees or more, then you're going to use three letters. So if I add another letter here, let's call this D, and I wanted to talk about this arc. Okay, it's more than 180 degrees, it's more than half a circle, so I would say arc ACD. And you can go backwards, so you can say DCA. But the point is you had to have a starting point and an end point and then some point in between so you know which way around the circle you're going. Okay, the minor arc is just the smaller one. So if I'm looking at the central angle ABC, AC would be the minor arc, and then the rest of the circle, the rest of the way around, is going to be the major arc. So this way from A to D to C is the major arc. Okay, so minor arc is AC, major arc would be ADC. Okay, and then a semicircle is just half of a circle, and so in the picture to the right, it would be arc EFG, and you don't have to have a measure on it, you just know automatically that it's 180 degrees. So I'm talking about the measure, I'll say measure, so little m equals 180 degrees. Because it's half a circle, a full circle would be 360 degrees. Okay, arc addition postulate is just about the same thing as segment addition and angle addition. The idea is that you can take a certain arc, so for example I can take arc AC, and its measure will be the sum of arc AB, so the smaller one, plus BC. So fairly intuitive, but that's your postulate. Like I said, similar to segment addition. Alright, so let's just look at a couple examples where we're looking for angle measures. Okay, so the first one is measure of KL. So KL is right here, and you can do this a number of different ways, but the first thing I notice is that from H all the way to K is half of a circle. So half a circle, remember semicircle is 180 degrees. I want everything except for the 136, so I'm just going to take 180 minus 136. Oh, thinking of the answer already. 136. And you get 44. Okay, so KL is 44 degrees. JL, let's see, it's from here to here. Let's get some different colors here. Here we go. Okay, so JL is this arc. And so it's consisting of KL, which remember this was 44. The angle will be 44 and the arc is 44. So they're equal. Central angle equals the arc. And then J to K is 62. So I just need to take 62 plus 44 to get my answer of 106. Okay, angle NPK. NPK. So I'm looking at an angle this time. But it is actually vertical angles with 136, it looks like. Yep. So those are going to be congruent, 136. And if you didn't remember that, there you could have added and subtracted from 180, or you could have gone about finding that other ways, but I just noticed the 136 and it were vertical, so that makes it easy. Now HJ, see, we need a new color. Okay, HJ, here we go. Okay, now do you guys see this half circle? So remember, that's 180 degrees. I want everything from H to J, so I'm just getting rid of this 62 part. Okay, so 180 minus 62 is 118. LPK, let's see, LPK. Okay, and we already found that because we found KL and the arc and the angle are the same, so that's 44 degrees. That one was easy. HPJ, HPJ. So basically everything HPJ is this. Everything in this semicircle except for the 62s. Remember, if the arc's 62, the angle's 62. So 180 minus 62. Hang on one second. Would be okay, 118. Okay, so then to get LHJ, I'm getting a lot going on here. Oops. Okay, so LHJ is almost all the way around the entire circle. It's basically everything in the circle except for the 62 and the 44. So if we just do 360 minus, so remember J to L was 106, so if we just subtract 106 away, we'll get our answer. Okay, so we get 254. Oops. Okay, and then the last theorem for this section. In the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent. And remember, if I have two congruent circles, this would be the minor arc. So if this is, say, 45, this would be 45. So if their central angles are congruent, then the arcs are also congruent, is what that theorem is saying.